Okay, 1.5. This is multiplying rational numbers. Okay, so basically we're multiplying. Again, this is review for you guys, so that's why it's not going to be that big of a deal. All right. When multiplying two numbers with two different signs, like positive and negative, the answer will always be what?
Positive.
Different signs will always be negative. It's okay. This is a review. So when you're multiplying, basically and dividing, but we're just focusing on multiplying today. When multiplying two numbers and with two different signs, the answer will always be negative. For example, -4 times +7 . What would this be with?
-28.
Very good. And y'all remember that when the numbers are in parentheses and right next to each other, it means multiplying. If I have 7 times -1, remember the dot means multiplying. What would that be, Emily? Very good. Good job. When multiplying two numbers with the same sign, positive and positive, or negative and negative. The answer will always be what?
Positive.
Positive. Same signs, positive answer. Different signs, different answer. I mean, different negative answer. As y'all have learned, and I explained to 7th grade today, it takes less brain cells to figure out positives and negatives when multiplying than it does adding and subtracting. Adding and subtracting, you actually have to think about it a little bit more. Do I add here? Do I subtract here? Which sign is it going to be? Blah, 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 blah. So it takes a little bit more effort. Multiplying and dividing, not so much. Okay. Example. -9 times -6. Michaela, what's the answer?
Right. Negative 54. Or, yeah. No, 54.
Which is it?
54. Positive.
Feel confident on that? Okay, she's correct. It is positive 54. Negative times a negative gives you a positive. Unfortunately, a big common mistake is that kids and adults, remember I tell you about stories on social media, kids and adults will associate these rules for when adding and subtracting. Totally different. Coach Cole and I, all summer, every time one of those, see if you're smarter than a fifth grader or, blah, blah, blah. If you can solve this problem, you're a genius. Those kind of things on social media. We tagged each other. Did I tell you about that?
Yeah.
We tagged each other the whole time. Did I tell you about the one that I was totally wrong?
Yeah.
I can't find it. I really want to find it. We were laughing about it yesterday. He sent me one. Did I tell you about the one he sent me this past weekend? I was like, no. It was. I asked him. No, it was bad. It had something to do like trigonometry or something. No, it's a dumb one you tagged me in. All right. No, I'm not Miss Rogers right now. All right, -3 times -9. Taylor, you want to do this one? Okay, go ahead.
Okay. Write it down.
What?
Positive 27.
Which is it?
Positive.
You feel confident about that?
Positive 27.
All right, positive 27. Come on, y'all, wake up.
I can't wake up.
Yeah, well, you're gonna have to try. All right, any questions about this? Cecilia, you doing okay? All right, don't make me move you up front.
I woke up 15 minutes earlier instead.
Oh, that's good. All right, properties. All right, remember those properties of addition we did? All right, here's properties of multiplication. I'm introducing, but most of these, not all, are common sense.
One. Common sense.
Commutative property of multiplication. And that means A times B. Remember when the letters are right next to each other, that means they're multiplying, right? Right? Right, Cecilia? So A times B is going to give you the same answer as B times A.
What's
Multiplication. So like I could say 3 times 5 is going to give me the same answer as 5 times 3. Yes? Hello?
Yes, ma'am.
Yes.
Do we agree that even though we switched the numbers around, that you're still going to get the same answer?
Yes.
Okay, good. Because 15, 15. Help you know that. All right, number 2. Associative. Is everything okay? Oh, okay. Associative property of multiplication, Michaela. Here, I'll write it out for you. Did I spell it right? Yes, I did. Okay. Whenever you see that word associative, it's referring to grouping. It's grouping in a weird way, changing the group.
Associate with.
Oh, I like that. Who do you associate with?
Is it a bit scary when he comes in?
Yes.
Like
No.
you're talking and teaching, and he's just watching you.
Well, he came in and just stared at the back of the room like at Taylor, and I was like, "What did y'all do?"
No, I'm just trying
Is
to
putting
write.
did he
desks
not-
together illegal?
Did he not come and just stare?
He
We're
did.
trying to write these.
I
and he's just
really
like,
thought one of y'all messed up, and I was like, "Man, why would you do that?"
Now we gotta
what if
deal
he
with all
watches
the
this
paperwork.
video?
Oh no.
No,
I'm still recording, y'all.
Oh, send it out.
Okay, moving right along. This would be like it would have A times B times C. You would still get the same answer. Oh dear. A times B times C.
Does he watch these?
I hope not. I hope he has too much to do.
He just watches and hears it.
I know.
Terrifying.
We didn't really say anything bad
Oh.
because, you know, we remember that we're recording. Okay. So it would be just kidding. Okay. So it would be like saying 2 times 5 times 3, and then just moving the parentheses over with the 2 and the 5. You would absolutely get the same answer. So all I did was move the parentheses. Instead of around the 5 and 3, I moved it to around the 2 and the 5. If you did the math, 5 times 3 is 15. 15 times 2 is what?
3. 12.
Okay. 5 times 2 is 10. 10 times 3 is 30. So you would get the same thing. Does everyone have this down?
Yes.
So you got it down? All right. Emily, did you get it down? Okay. All right. Property number 3.
The common sense, bro. That's good.
I'm still laughing in my head about that. That is hilarious. I gotta remember I'm recording. Okay, this one, look at the word identity. It's kind of like the one we did with addition. This is saying that A times 1 is the same as 1 times A. The answer will always be the same. So for example, 5 times 1 will give us the answer of what? 5. If I do 1 times 5, I get the same answer. So switching the numbers around makes no difference. Same with adding, subtracting's not like that, but adding and multiplying. Again, common sense, they have a name for it. Now, number 4. I'm going to put 2 stars by number 4.
5 stars distributed.
It is a distributive property. Now, out of all of the properties you're going to learn, this one, as you remember from last year, is, I'm not going to say the most important one, but the one that you actually have to know. All of them are used, but the others are common sense. This one is as a property that you actually have to learn. That's the difference. And that is saying, this is important. A times B plus C. If these cannot be combined, the B and the C. If you can't combine them because maybe it's a letter and a number or something like that, they're not like terms. So then if you remember, you're multiplying the outside by everything on the inside. And that gives you A times B plus A times C.
And that's the answer. Right?
Yeah.
AC.
So like 3 times x plus 7. The x plus 7 cannot be combined. Normally you combine everything in the parentheses and then you can multiply it. Well, in this case, this doesn't work. You can't do x plus 7. So we multiply. 3 times x is what?
3A.
Plus, because of that plus sign, 3 times 7.
21.
There you go. And yes, that would be the answer. Because you cannot combine those. They're unlike terms. Any question? Isn't it nice to have had pre-algebra first? I always worry about the kids that come here from outside the school that haven't had a full year of pre-algebra. I mean, they can do it, but it's a little bit harder. This is like, man, this is review. We already know this, you know? So, it's nice. All right, and then the last one, 0.
I thought they said two,
Ignore him.
fair enough.
My physical therapist says that over and over again. Fair enough. Fair enough.
My ankle hurts. Fair enough.
You broke my leg. Fair enough.
All right, that's saying that anything times 0 is 0. Again, common sense. 4 times 0, 0.
It's the most difficult one.
Yes. That one and the identity one.
Yeah.
Okay, when you're done writing this, put your pencil down so I know you're done.
Number 6, the Taylor property.
What does that mean? 8 times 0 equals 0, 4 times 0 equals 0.
I'm saying this part and this part, that's the actual property, like definition type thing. Then underneath I give you an example without the letter. Anything times 0 is 0, right?
Oh, okay, yeah.
Is that like the formula?
Yeah. All right, so remember, work left to right. Boys and girls, I am aware that if everything in the equation is multiplication, you don't have to necessarily work left to right. But you need to practice working from left to right. Okay? Because you know stuff is coming that's rough. Okay? Especially in Algebra 1. So practice working left to right. For example, Taylor, work left to right.
That's what I do anyways.
Okay, good. So, for example, Cecilia, we're going to start with -2 times -3. What would that be?
-6, +6.
Which is it?
6.
Are you confident? All right. Yes, +6. Bring down the -5. Taylor, you will write down every step. Cecilia, you will write down every step because it's going to get ugly. Michael, what is 6 times -5?
-30.
Very good. Any questions?
No.
Let's do another one. Absolute value, -2 times absolute value of -3 times absolute value of -5.
Times.
Let's see, Aiden.
You turn it back. 2 and 2. So you just bring them all down, right? You and 2 and 2. It'll
What is the absolute value of -2?
2.
What is the absolute value of -3?
3.
Gabby. What is the absolute value of -5? Emily.
Is that the exact same problem just with,
Maybe.
I don't know,
So then what is the answer, Taylor?
30?
Is it negative or positive?
Positive. I don't see any negatives.
That's right. There's no negative, so it's 30. Any questions?
+2 times +4 equals negative.
Put your pencil down. Taylor, stop talking. Put your pencil down when you're done writing. Let's do another example. negative 4.28 times 5.31. Gabby, you want to do it? Okay, so boys and girls, Gabby, you can do it on the side of your paper. Listen up. If you're like, I have forgotten how to multiply with decimals, do they have to be lined up?
No.
Not when multiplying, they don't. They do not have to be lined up. So you go ahead, in this case, it just happens that they are, but you don't have to. Hopefully you remember how to multiply a 3-digit number and a 3-digit number.
If not, well.
And then Gabby, when I want y'all all to be working it, Gabby, don't yell it out yet. I want all of you to be working it and see if y'all get the answer she gets. All of you are working it. All right, Gabby, what'd you get? Yes. Negative 22.7268. Now, if you have forgotten how many total places in the problem are behind the decimal, everyone, how many?
4.
There's 1, 2, 3, 4 total places. So there should be 4 total places behind the decimal in the answer. Okay? Hopefully, if you did not get this answer, it was a mathematical error over here.
Yep.
Okay? All right. Moving right along. Example, negative 3/4 times negative 7/8. We're multiplying fractions. Michael, tell me how to multiply fractions.
You just multiply the numerator into numerators.
Just the
And
numerators?
the denominators.
So you multiply across. Okay, so what would you get, Michael? Is it negative or positive?
Positive.
Okay, it's positive because it's 2 negatives times each other. And what do you get?
21/32.
Very good. Because 3 times 7 is 21, 4 times 8 is 32. Any questions? I have one more for you. Let's see. Big old 2 1/5 times big old 4 2/7. Aiden, how do I do this?
When you go first, you do 5 times 2 plus 1.
There you go. 5 times 2 plus 1. And what do you get? 11/5. So you keep the denominator. Do y'all see that? All right, Aiden, what do I do over here?
7 times 4 plus 2.
And what do you get?
30/7.
30/7. You keep the denominator. Who here remembers cancellation? All right. Taylor, what can I cancel here?
5 and 30.
Okay, so I can look at the 5 and the 30. 5 can go into 5 and 5 can go into 30. How many times can 5 go into 5?
Once.
And how many times can 5 go into 30?
6.
Can I do cancellation of 11 and 7, Taylor?
No.
No, because there is no number besides 1 that can go into it. So now I can multiply across. Cecilia, what is 11 times 6?
66.
And what is 1 times 7? So, okay, Cecilia, very good. There you go. Are there any questions? Think you guys got this? All right. You're doing page 26 to 27. You're doing numbers. I think today's going to be everyone.
So no. Second one for honors.
No, don't have any good ones.
Can we have a bonus?
No, we don't need that.
But it's
Look at it as, okay, we don't have that much to do.
Wait, Miss Rogers, you said that the grade for just algebra is going on college then? Or is it all of the
No,
subjects?
just algebra.
Okay.
Hold on. Maybe I will do more.
bonus.
32, 34. Let's see how. Hold on. Okay. And then 44 to 52 even. This is due Friday. That's like 14 problems. Your quiz is Monday.
It's 13.
Whatever.
We were gonna only have 6 problems.
Yeah, right. Okay. And you can get started.
Do you have a bonus there?